Hello everyone, I'm Rivka. We are from Group Megamind, which is Group 21. So these are my group members, Marsha, Hajar, Lee and I. Now we are going to present about experiment 10, which is pressure drop in packed bed. Firstly, I will discuss about objectives of this experiment. So, the objectives of these experiments are to determine the pressure drop of packed bed and fluidized beds for water system. Secondly, to determine the onset of fluidization. Thirdly, to verify the friction factor of packed bed. Fourth, to determine frictional loss in air system. And lastly, to plot Reynolds number against friction factor. Moving on to the theory of pressure drop in packed bed. A packed bed is a cylindrical column which is packed with an appropriate packing material. A gas is admitted at the bottom and flows upward in order to contact in the counter current with the liquid, which is distributed at the upper part of the column and flows downward to wet the packing material. Pressure drop plays important role in determining size of the blowers or pumps required to force through a packed bed and estimating operating and capital costs of the packed bed. However, pressure drop depends on type of packing, bed void fraction, properties of fluid, as well as the flow rate of fluid. Argand equation is also the most common equation used in order to predict packed bed pressure.
Hello, my name is Sita Hajar and I'll be explaining the procedure of the first part of the experiment. The first part of the experiment is conducted by using the ceramic spheres. Firstly, we have to add the ceramic spheres into the column until the bed height of 100 mm. But before that, make sure you turn off the power supply to avoid any kind of accident. After that, the main switch of the power supply is turned on, followed by turning on the airflow in order to allow the air to flow through the column. The variable flow rate was set by adjusting the control valve to the desired flow rate starting from 50, 100, 150, 200 and 250. The differential pressure reading was recorded from the digital manometer that is located right above the flow meter. And finally, the whole steps is repeated using ceramic spheres with a bed measuring of 130 mm.
Hello, my name is Lee Wenshen. Now I will explain the verifications of friction factor for air system. The first procedure will be the power supply was turned off while the ceramic spheres were added into the column to the height of 100 mm. And the second step is turning on the air pump in order to allow the air flow through the column. So the third step will be the adjusting the control valve below the digital flow meter for the desired flow. And the fourth step is all the differential pressures were recorded for each trial. And the following one is step 1 until 4 were repeated with ceramic spheres measuring a bed height of 130 mm. And step 1 until step 5 were then repeated by replacing the ceramic sphere with acrylic pellets. And the last is we collect all the data in each trial to calculate the things in the experiment.
Bismillahirrahmanirrahim. My name is Marsha binti Muhammad Najib, and I'll proceed with the results and also the discussions part. As you can see, this is the eliminations of pressure and height variation with the flow rate for air system, for ceramic sphere and also the acrylic. So the bed does not affect and change the behavior of fluidizations. The significant difference only shown by the ceramic particles with the difference of height, but not the acrylic particles. As the bed of height increases, the minimum fluidization's velocity increases, and this had led to more pressure is needed to reach a minimum fluidization's velocity for particles to move. The main reason is because the concentrations of the particle increases and resulting in a large amount of frictions and pressure drop as the air entered the packed bed. Next is the ceramic particles with a larger diameter. We can observe that it results in a bigger pressure drop as the air enter the packed bed as compared to acrylic pellet. This is because as the particles that are in the packed bed in a large size, it will create more resistance towards the flow, and therefore a large value of pressure drop is needed to achieve a minimum fluidization velocity. So, as for the conclusion, we can conclude that as the height increases, the pressure drop will occur, and the frictions was increases in the tube due to the increasing of the height of the packed bed. Pressure drop was slightly higher in ceramic sphere compared to acrylic pellet. So thank you for listening. Have a good day.